everyone, and welcome to the Global Mapper webinar for the month of July. During today's presentation, which will be about 60 minutes in duration, we will demonstrate how Global Mapper provides accessible GIS tools for municipal or local governments of every size. Among the topics we'll be finding and importing geospatial layers from numerous sources, working with parcel or property information, using field-collected data in Global Mapper, and creating and analyzing terrain data, and sharing maps and data layers with constituents. If you have any questions during the presentation, you can use the Questions tool on the GoToWebinar panel to the right of your screen. Our panelists will try to answer your questions as they are submitted, and, if necessary, the presenter will address any outstanding questions at the end of the presentation. We will respond to as many as we can during the session and will follow up via email on any remaining questions. Remember, for ongoing questions about the features and functions of Global Mapper, you can always email our support team at geohelp@bluemarblegeo.com. Before we begin, we would like to announce upcoming dates where you can come out and meet some of the Blue Marble staff and learn more about our products. From September 16th through the 19th, we will be exhibiting and presenting at the ERISA GIS Pro Conference in Providence, Rhode Island. On October 30th, we will be hosting the 2013 Blue Marble User Conference at the Royal Sonesta Hotel in Houston, Texas. This is a great opportunity to hear about the latest developments at Blue Marble, to learn how other users are using Blue Marble products, and to network with other users. If you are interested in presenting, the call for papers is now open. Please click on the User Conference link in the About Us menu on the bluemarblegeo.com for more information. At this time, I would like to introduce David McCritchard, Senior Application Specialist at Blue Marble.
Thank you, Jasmine, and thank you all for taking time out of your day to attend the latest in the Blue Marble Geographics webinar series. This month's is entitled Accessible GIS for Municipal or Local Government. We are going to be spending time today looking at our Global Mapper software, our desktop GIS tool, and specifically we're going to be looking at the application for that software in the field of municipal or local government. Now, this is a little bit of a change for us in terms of our webinar content. Typically, we deliver webinars that focus on a particular component of the software, perhaps a new function, or perhaps focus on the new features that were added during a particular release. Well, this is different. We're actually going to look at how the software is going to be applied in a particular situation and the various tools and the various components of the software that are relevant in that situation. And as I said, we are going to be looking at municipal or local government applications for Global Mapper software. As far as an agenda is concerned, we're going to begin, this is based on the assumption that many of you are perhaps new to the software, we're going to begin by asking the question, what is Global Mapper? A very high-level overview of the key components or the defining characteristics of the software. One of the challenges for smaller municipalities or smaller local government departments is accessing data. Where do I begin? How do I begin the process of developing my GIS? So the first part of our demonstration today is going to address that question or that issue. How do I get data and import it or apply it to my GIS? And we're going to show various mechanisms where you can access different data sets. One of the primary GIS data sets that you will be working with, that many municipalities work with, is a parcel data set, property ownership information. We're going to go through a hypothetical scenario where we're going to build and develop a parcel data set and show you how you can create that data set, how you can manipulate it, how you can add attribution, and ultimately how you can share it with your constituents. So a large part of what we're going to be doing today is going to focus on managing parcels. Another source of data for many GIS users is field-collected data. Perhaps you have a GPS receiver and you can go out into the field and collect location information. We will walk through a specific scenario that shows you how to import that field-collected data and again integrate it into your GIS. One of the specific analysis tools that we're going to be looking at is the ability to generate buffers, a buffer being an area feature that extends from either a point or a line or a polygon or a collection of points, lines, or polygons. It's great for determining impact or the extent of a feature, of the influence of a feature. And we'll go through a couple of scenarios where we'll be using buffering within the software. One of the major development focuses as far as Global Mapper is concerned over recent months has been the enhanced elevation data analysis capability. We're going to be looking at that tool specifically towards the end of our presentation, working with 3D data, generating terrain models, generating contours, and then doing things like flood analysis or watershed modeling. So we're going to be focusing on a lot of those essentially 3D analysis capabilities that are available within the software. And finally, and probably most importantly, is the ability to share data. We want to make sure that we cover the various tools within the software that allow you to share data layers or share maps or share whatever information you've been processing or managing with your constituents or with your colleagues or with your clients or whomever you work with. So a major part of any GIS is the ability to share data in an interoperable way. And we'll talk about some of those features of Global Mapper later in our presentation. As you can see, we've got a lot to cover today. First question on my bulleted list is, what is Global Mapper? So I'm going to quickly bring up a second slide that addresses that specific question. My first bullet says it's a fully functional and easy to use GIS software package that costs under $400. Now, hopefully by the end of today's session, the low price point that you're seeing here will become a little more meaningful because you will see and appreciate the volume of functionality that you get for that price. I should also mention that that $400 is a single time price. There is no annual fee, nor is there a maintenance cost that you have to pay to use the software. This is a one-time cost. You buy the software, it's yours to keep. Global Mapper provides unparalleled access to hundreds of spatial data file formats. We're going to be working with a couple of different types today, a few of the more common types, but the format support list within the software has reached over 200. Now, chances are most of you will not need to address most of those formats, but the important consideration here is Global Mapper is completely interoperable with whatever other software you may be using or you may have access to, both in terms of importing and in terms of exporting, and we will address both of those issues when we get into looking at the software in a couple of minutes. The software provides a variety of tools for both drawing and for editing map features. This is key in any GIS software. Accessing pre-existing data is great, but eventually you'll want to get to the point where you're actually doing your own data management, your own data manipulation, your own feature creation, and we'll talk about some of those tools a little bit later in our presentation. The software does include a wide array of analysis functions. As I mentioned when we were talking about elevation, we have tools for doing watershed modeling or watershed delineation, flood zone modeling, viewshed analysis is another one. We have a lot of different tools that let you derive important information from whatever data you have imported into the software, and we will hopefully have time to touch on a couple of those during our presentation today. We like to think that Global Mapper provides just the right level of GIS functionality, whether you consider yourself to be a GIS professional or whether you're just starting out. The software is certainly accessible for those of you who have not had any formal GIS training and perhaps appreciate the value of a GIS but have no current experience. This is a great tool to begin the process of learning GIS and for developing your own GIS. Now let's take a quick look at the software itself. I'm going to switch windows here, and I'm going to bring up Global Mapper. This is the interface for the software. Now this is the introductory interface. Obviously there's one thing that's missing here, which we will rectify in a few minutes. There is no actual map itself. We're going to talk about that and how we get that map information into the software. But just by way of beginning, let's take a look at the overall structure, and it's a fairly standard Windows-based software structure. We have menus. We'll be looking at some of these menus as we go through various scenarios and workflows. We have an analysis menu that allows us to perform analysis. We have the file menu that lets us import or export data from various sources. So we're going to be working through various scenarios in which we go to the menus to access those functions. The commonly used tools are available in our toolbar. The buttons you see at the top of the screen provide access to, as I said, those commonly used tools. We'll be using many of those during our scenarios today. And then the main map window itself. By way of introduction to the software, we provide a couple of quick buttons that give you access to many of the tools that you'll use, or the common tools that you'll use by way of getting started. Opening existing data or downloading online data. We're going to address that specific issue in a few minutes as well, accessing data from some online sources. So as an introduction to the software, we provide very easy to read large buttons right in the middle of the screen to get you up and running. Now, in my introductory bullets, the first challenge that we were throwing out is the getting started. Where do I begin? How do I get data? As I said a minute ago, my map is empty right now. We need to rectify that situation. How do we get data into Global Mapper? Well, the first source I'm going to talk about is pre-existing files. If you live somewhere within the US, or perhaps in Canada, or obviously in any other country, chances are a government agency, whether that be state, province, or national government agency, will provide access to many pre-configured data sets. I want to show you an example. We're going to be focusing today in the state of Minnesota. We're going to be working with some data files from Minnesota Geospatial Information Office, as well as some more localized files as well. So I'm going to bring up the website for the GIS data that's available for folks in the state of Minnesota. And as you can see, there's a number of links here to things like aerial photography, elevation data, geology, land ownership. I'm not going to go any further into the site than this, but this is a great starting point to access data, to access some pre-existing files that you can then import into Global Mapper to begin the process of the development of your GIS. Now, what I'm going to do now is actually show you what that would look like. I'm going to use the big Open Your Own Data Files button right in the middle of my screen, and I'm going to browse to one of the files that I downloaded from the site that we just looked at. And this happens to be for the county of Clay, which is in the state of Minnesota. I have a shapefile that delineates jurisdictional boundaries. As an example, before I go any further, I want to point out, as I mentioned in my introduction, the wide array of formats that you can begin with. Whether you have CAD files or files from some other proprietary software, this list is over 200 files long, and that is increasing. This list is increasing as new formats are added to the list. So don't be intimidated. You don't have to understand all of these formats. What's important is the formats that you work with are likely going to be supported in here. The file that I'm pointing to is a shapefile. This is probably the most common GIS format. I'm simply going to open that file, and it automatically imports that. And now I have a map to look at. This is an shapefile with area features. I'm going to use a tool in my toolbar called my Feature Info tool, and I'm going to select one of the features, and you'll see it provides a snapshot of the information that's assigned to this particular feature. This is a pre-configured layer. This is a layer that I did not have to work on, I did not have to create, and Global Mapper imported it automatically, and it provides a good basis for whatever other projects I need to do. And again, from those public archives, you can download multiple data types and build your GIS data layers as needed. I'm going to unload that data. We're going to be working with a number of different data sets. I'm going to unload this data, and we're going to show you some other sources of data. So clean up my map. The second button on the screen says download free maps and imagery. This is basically an online access point. The little globe button in my toolbar does the same thing. I'm going to click the globe button, and it brings up a window that provides access to some pre-configured and remote data sets. If I take the example of imagery and I expand that list, you'll see a number of the available data sets, some of which say premium content. These will be data sets for which you need a subscription. You need to have a subscription from the provider to access those particular data sets. But there are also a number of free data sets, some satellite imagery, some aerial imagery from the US Department of Agriculture, the NAPE data, and we have this world imagery data set as well. So you can choose a source of data, define the extent of what you need if that's necessary, and simply hit connect, and it will render that file right on the screen, or render that map right on the screen. This is a remote connection. It's like it's streaming the data over the web. Typically, if you're accessing data using this mechanism, we would recommend you save whatever section of that data you need to a local file, so you do not have to depend on access to the web to access those files. I'm going to show you an example in a couple of minutes of some of those saved files. Before we go out of this window, I want to show you some of the other data sets. We have terrain data, elevation data. Later in our session, we'll talk more about working with elevation data within Global Mapper. We have topographic maps. Again, we've got some pre-configured. You also can add your own sources. We have an Add New Source button right here, and you can add your own sources. If your state has a web mapping service, a WMS, you can connect directly to that service and pull those maps directly into Global Mapper. Now, in the interests of time and not depending on the availability of bandwidth, I'm going to show you the end result of that procedure by importing a couple of files that were pre-configured. I'm going to go ahead and use my open dialog box once again, and I'm going to load up some topographic data. I actually have this pre-saved. Actually, I'm not. This is going to be imagery. I apologize. This is going to be some imagery. So we'll go ahead and open up a pre-configured file that has a small tile of some imagery. This, again, represents what would have been downloaded from one of those online sources. I saved this locally. I cropped the imagery out to a defined area, the area that I was interested in this case, and I now have this file locally stored. I can open it up very quickly, and I do not require web access to work with this particular file. So we've talked about accessing pre-configured files, the shapefile example. We've talked about accessing data remotely and obviously saving that locally if necessary. The next source of data I want to talk about is something you may have already worked with, you may have access to within your municipal offices, and that's paper maps. Paper maps very often form the entire GIS infrastructure for small municipalities. That's all they have. All of their map work is done in a paper form. And the challenge for many of those municipalities is transitioning from that paper-based map system into something digital that they can work with and manage and interact with. I'm going to show you how that procedure could work for you. Obviously, the challenge is to generate a digital copy of those maps. Perhaps use our parcel maps. If you are able to do that, if you're able to get digital copies of those maps, perhaps in an image format or perhaps in a PDF, you can then import those directly into the software and align them geographically. And that's exactly what I'm going to do right now. I'm going to open up a file that's actually just an image file. It's a JPEG. It doesn't have any inherent geographic reference information. I believe it's in image rectification. We'll just go ahead and open up that file. And it's a sample of some parcel data. It's just a JPEG with some parcel or property ownership information in a picture form or a JPEG form. Now, Global Mapper is already prompting me here to tell me that that file that I'm trying to import is not geographically referenced. In other words, Global Mapper does not know where to put it. The option I'm going to choose here is to manually rectify the image. So in this case, I'm going to click the Yes button. And it'll pop up a dialog box that allows me to essentially position this image relative to the data that I had already imported. I have a little tile of imagery, and I have the corresponding area with my property boundaries or my parcels in picture form. The way this process works is I would identify a location in this imported file and either tag the corresponding position in the adjacent image, or if I happen to know the precise coordinates for that location that I've tagged, I would simply manually enter those, and after doing that several times I could process the file and I would import the picture as a geographically referenced file. Now I'm going to cheat a little bit here because I've actually done this by way of preparation. I'm going to load a file that contains my pre-configured control points. And you'll see scattered throughout the imported parcel map I have several identified points, and I also have the points now tagged to the corresponding location in my existing map. In other words, the map that is already geographically referenced. You'll also see in a tabular form the same information at the bottom. If I click OK, the results of that process will be that that little section of image is now positioned geographically. I now have two layers, the original layer that I downloaded and the imported, formerly paper map that was in an image form that is now a geographically intelligent layer. I'm going to open up my Overlay Control Center, which is the component of the software that lets me visualize the layers that I'm working with, and we'll be using this a lot over the course of the next few scenarios. And you can see I can turn the individual layers on or off as needed. I can also use what's called our Image Swipe tool, and I can pull back one layer to take a look at what's underneath. And obviously in this case we're dealing with two image layers or two raster layers, so you can't really see both at the same time, at least not in their complete form. So we can, as I said, pull one back from the side or from the top, whatever, and see the other layer underneath. Another thing that we can do is we can adjust the transparency of one or other of these layers. I'm going to select my Parcels layer, and for that particular layer I'm going to open up the Options dialog box. And you can see there are a number of options for changing or altering the visual characteristics of this layer. For instance, we can change the cropping, we can cut out a small section, we can adjust the colors, or we can adjust the transparency. And that's exactly what I'm going to do right now. I'm going to pull my transparency slider somewhere to about 30-35%. I'll just pull it out of the way so we can see the results of this process, and we'll click Apply. And now you can see not only the underlying imagery, but a muted version of my imported parcel map. Essentially, I can see both the properties themselves, the buildings and the other features, and the delineated line work that allows me to essentially look at the property outlines. I'm just going to click OK, and we'll zoom in on a particular location now. And we can get a closer look at the end result of that process. So again, we're looking at the buildings, but we're also looking at the line work from our imported and registered map. So that's another method for getting data into Global Mapper. Registration or rectification of perhaps image or perhaps PDF files. I'm going to change focus slightly here and talk about another way to essentially get data or create data in this case, and that's through the digitization process or the drawing process. In my toolbar, there are a number of tools that let me draw features. Now, before we actually embark on the process of creating any of these features, let me show you a couple that are particularly useful. My cursor currently is hovering over a tool called Kogo. In the interest of time, I'm not actually going to demonstrate this, but this Kogo tool allows you to create a feature based on its known dimensions. So if you're embarking on a process or a project in which you're trying to outline perhaps a property and you know the precise dimensions of that property, perhaps this is based on an existing legal description, you can simply enter that information manually rather than trying to manually create the feature by clicking on the map. In other words, you can guarantee the preciseness of that feature you're creating by entering in the precise dimension. So that's a tool that's available within the software. I'm going to simply trace some of these parcels that I've imported. I'm going to show you how that process works. And for this, I've created, or I've selected my area tool. And without any too much care, very quickly, I'm going to essentially outline the bounds of my first property. And when I'm completed, I'm given the opportunity to assign whatever information I can to what I've just created. I can give it a name, as you can see at the top of this window. I can assign it to a particular feature type. I had a previously created parcel, so it's remembered that from before. That allows me to automatically determine the visual characteristics, in other words, the shading pattern, the fill pattern, the outline pattern if necessary. And I can also pre-configure whatever attribution is important for this particular feature. Now, in this case, the only attribute that's going to be assigned to this new feature is called Object ID. We're going to be talking more about attributes in just a little bit. We're going to be talking about how you can manage the actual information that's associated with the parcels. But for the time being, I'm simply going to click OK. And my new parcel has been created. That is in a vector form. I'm going to turn off my original imagery and my scanned map, and I now have a feature derived from my scanned and imported parcel record that is now in a digital form that I can use to manage whatever information is associated with each parcel. So that is the process for extracting information from a scanned layer and making it into a more manageable form. I'm going to create an adjacent parcel, and I'm doing this because you'll notice that there is a snapping function. So if I begin the process of creating a new parcel, that line work will automatically snap. So again, I can guarantee that the parcels are contiguous, they're not going to be overlapping, or there's not going to be any gaps between. There are a number of advanced functions you can also apply when you're delineating features like this. For instance, here we have a road, and obviously the road would form the boundary for each of the abutting parcels. You could generate a road polygon derived from a buffer of a center line perhaps, and that could form the boundary of the parcels that follow that particular road. So there are a number of more advanced tools that you can employ to generate the geometric parcel record. Now, my approach to this webinar is a little bit like a cooking show, because I'm going to show you a completed parcel database that I prepared previously. I'm not obviously going to spend the time to delineate each of the parcels, so I'm going to remove all of the data that I have currently loaded. I'm going to simply wipe the slate clean, and I'm going to open up another new file. And this new file is going to have the parcel record for the little community of Hawley, which is in Clay County, Minnesota. And the end result of the process of delineating parcels may look something like what you're seeing on screen. If I use my feature info tool, like I had done previously, I can select a parcel, and you'll see each of them has what was previously created, an object ID. And by way of creating those, each one is unique. Each one has its own identification number. Now we're going to be coming back to our parcel database in just a little bit. We're going to talk more about adding attributes, adding more meaningful information. But before we get there, I want to show you one other mechanism for getting data into the software. So far we have dealt with pre-configured data, online data, and manually created features. The last example I'm going to show you is basically a text file that simply contains location information. I'm actually going to preview that file before we import it. This file represents the location of some fire hydrants, and this is simply a text file. Hard to see the full extent of the text file in Notepad, but basically the first two columns, this is, by the way, it's tab delimited. The first two columns represent my latitude, my longitude. We then have an object ID as well as some additional information. Now I use this file as an example or an illustration as to how you can get or how you can create a layer simply from some coordinate values. This may represent data that was collected on a handheld GPS device, obviously without the additional attributes. But if you go out with a handheld device and you tag the location of certain assets, you can go through the process I'm about to show you to place those features right on the map. Now, as you can see, this particular example represents some fire hydrants. So I'm going to import that file, and I'm going to create my fire hydrant layer. The way I'm going to do that is slightly different than what I had done previously, where I just essentially went through my open dialog box. This time I'm going to open a generic ASCII text file, and I'm going to browse to the hydrants file that we had looked at previously. Now there's going to be a couple of decisions or a couple of tabs and a couple of dialog boxes I'm going to have to work with as I go through this import process. The first one allows me to determine the characteristics of the features that are imported. I'm going to import points in which my latitude is first in the first column and my longitude is second. I'm going to automatically assign those features as hydrants. So I'm going to choose hydrant as my feature type, and this is something I had created previously. And we don't have any elevation data, so we're not concerned about having any Z value or elevation value in this data. And I want my column headers to be acknowledged as being in the first row. So I think all of those settings should be fine. And I'll click OK. the X and Y values, the coordinate values, the global mapper just sees a series of numbers, so I need to tell it what those numbers are, and in this case we know they are geographic latitude and longitude, so we can just leave these settings as they are and click OK. And as you'll see, I have a series of hydrants. Those were simply coordinate values. I assigned them to a particular feature type called hydrants, which allowed me to specify the appearance. And if I use my info button once again and I select a hydrant, you'll see I've got all of the information pertaining to that particular hydrant. So another method for getting data into Global Mapper. Now before I continue, I want to actually take a little bit of a side path here to show you a workflow that would be useful in this context where we have hydrant information overlaid on top of our property boundaries. First thing I'm going to do is I want to select all of those hydrants. I right-clicked on the layer that I had just imported and I want to select all the features. Now the designation of being selected is indicated by the fact that they're bounded by a red box. Now that they're selected, I'm going to go through the buffering process to create a buffer, or rather a series of buffers around each hydrant. The analogy here is obviously the hydrant has a certain range, so I want to see, based on that uniform range, which areas of town have coverage and which we might need to address with additional hydrants. And this is again just a hypothetical example of an analysis function that can be performed within the application. So with those features selected, I'm going to choose my buffer tool and I want to define a buffer range. In other words, this is the distance from each hydrant that the water can flow. I'm not a fireman, so I'm not sure if this is precisely the value that will be appropriate, but again, to show you the functionality of the software, we'll assume it's 400 feet in this case, and we want to make sure any overlapping buffers are combined into a single feature, and we'll simply click OK. And as a result of that process, you'll see the delineated extent of my hydrant coverage. I'm going to zoom in a little bit and you can see there may be some areas of concern in town. For instance, right down in this area we've got coverage extending to a certain part of the street but not to another part. So this is just an example of how you can use some of the tools in Global Mapper in the decision making process and determining, in this case, coverage for hydrants. And obviously you can address that issue, your public works department can go out and make sure that you've got complete coverage. So buffering is a tool that we can employ to perform that type of function. Okay, as I mentioned previously, when we imported our parcel record, let me turn off my hydrants and my buffer and we'll focus once again on my parcels. When we imported our parcels, or when we created our parcels, we created the basic geometric structure and we assigned a single attribute. Well, obviously each of these properties has a lot more information pertaining to it. I'm going to show you, before we begin this process, what that information may look like. And chances are, if you work in municipal government, you're familiar with this type of file structure. I'm going to open up under my Parcels folder, right down at the bottom, what we call attributes, the information that pertains to each of those parcels. Now this is a long list of information, things like the property value, the owner information, the date it was, the year it was built. All of this information currently is in a spreadsheet. It's in a tabular structure. We're going to take this data and we're going to go a long way with it. So I want us to make a mental note of where we started. We started with simply a spreadsheet, a list of properties with all of the appropriate information. The first thing that we're going to do is we're going to associate each line item in that spreadsheet with the appropriate parcel in our layer. And we're going to do that through a process of joining. The way that works, if I select my parcels layer and I right click, we have the option to join a table. And I'm simply going to point to the file that we just previewed and I'm going to open it. Now there are various decisions I need to make in terms of how the file is structured. Well, it is a comma delimited file that I'm trying to import, so we'll leave that one as is. The component of that file that's going to provide me a link between my existing data and that external data is the object ID value. This is going to provide that ability to match one-to-one. The same value is included in my currently created layer and in my external data that I'm hoping to join. So object ID is that linking field both within the internal layer and within the layer that I'm importing. Now when I click OK, it's going to happen pretty quickly. We get a report that all of the 1,131 features have had a successful match. So that process took less than a second, and as a result, if I click on one of my parcels again, we can now see not only the object ID, but all of the appropriate information that was previously in my spreadsheet is now associated with each record. So it's a very, very powerful tool that allows you to essentially build this information or assign this information in a geographic context. Having that parcel data now associated with features on the map, essentially having it geographically applied, we can start to work with this in a more analytical way. I'm going to show you a couple of functions within Global Mapper where you can utilize that data or visualize that data in a couple of different ways. Now the first example I'm going to show you is a very simple search tool. I'm going to open my search dialog box, and the search dialog box gives me a preview of all of the attribution, all of the attribute fields for each of these records. And we can build a query or we can build a search to allow us to filter the data based on whatever criteria that we need. The first search I'm going to do is going to be based on the actual value of the property. So if I select, believe it's called EMV total, which is our total value, as my attribute to search, I'm going to select a search in which my value is greater than a specified amount. And the amount in this case is $300,000. Make sure I have the right number of zeros here. And this is a numeric field, so we want to address it as such. So basically this search is going to filter this list down to just those properties that are over $300,000 in value. And we will just run a new search. And the results, as you can see perhaps even from the scroll bar, are a filtered list. These are just the most expensive properties in town. Now one of the other fields I have here is called class, and the class denotes what type of property it is. We have commercial, industrial properties, we have a church, we have schools. I'm most interested at this stage in just the residential properties that fall within my value range, in other words that are over 300,000. So I'm going to conduct another search. In this case the field I'm going to choose is class. I'm going to do an equals operator this time, and you'll notice within my class we have properties that are noted as residential, abbreviated to REZ. I'm going to search based on a couple of wildcards. The little asterisk is going to give me a wildcard. I'm going to type RES as my wildcard, and this is a text search. So again, under the field class, I want to find those that contain RES. Now I don't want a new search at this stage because that would essentially override what I'd done previously. I want to retain the initial filter, but rather I want to search within the existing results. And if I click that option, I have further filtered my property. I've got residential properties that are over a total value of $300,000. I'm going to select all of these. I want to right click and I want to select them on the map with my digitizer. The digitizer is the tool that lets you apply modification to features on the map. And you'll see when I do this, if I close the search window, let me zoom out just a little, you'll see the properties that were the result of that search are now highlighted on my map. I can see where those more expensive residential properties are located. So we could have conducted a search in our spreadsheet, but here we have the same results represented geographically and showing us a definite pattern. The northwest corner of town is obviously where the more expensive properties are, perhaps some of the newer subdivisions are. With these selected, I have the opportunity to apply any modification that I want. I can right click and I can edit, and it will edit just those features that are selected. I can go into the attributes for any of these selected features and again make a modification. If I want to denote these as having a special criteria, I can denote these by modifying an attribute or by creating a new attribute if that's necessary as well. So that's just one way we can interact with the data. I'm going to show you another way that we can visualize various components, various elements of the data that we've joined to our parcel record. The visual representation of my parcels right now is determined by the fact that I made them all parcels, and this orange outline was the color that I had selected. Using the options for this selected layer, my shapefile, I have the option to change the style. I can do various things. I can determine a specific style. If I want everything to be red instead of orange, I can make that choice. I have an option to assign random colors, which gives you a nice checkerboard multicolor map. I'm not sure how useful it is. Perhaps the most useful component of this dialog is the ability to apply styling based on an attribute or name. In other words, based on the value that we select. I'm going to choose a couple of examples here. The first one is going to mirror what we looked at a minute ago, which is our total value. I'm going to derive a shading pattern based on variations within the values of the property. The map that we create should show us those different color patterns. Now, this process, if I was to do it in real time, I would create the value thresholds that I want in order to save time. I actually have done this already, so I'm going to click load from file, and I'm going to choose my total value style. All I'm doing here is basically loading a pre-configured color style that I'd created previously. So variations on the shade of green will denote increasing values of property. And I'll click apply on that. And I'll keep the window open because we're going to do another one in just a second. But here we can see visually, the darker the green, the more expensive the property. And you can see the distribution of the values of properties throughout the town. Here again, if you compare this to where we came from in terms of our spreadsheet, we're now getting a visual representation of those distributions geographically. I'm going to do another example. Let me go ahead and close or delete what I'd done previously. And we'll change the field. In this case, there's a field called year built. This is an interesting one. One of the joined columns denotes the year in which the buildings were built, and I'm going to represent the year built on my map as well. And again, in the interest of time, I have this pre-configured. I have a style that I pre-assigned, and the threshold years you'll see noted in here. This is obviously not every year, but I established certain thresholds, and again we'll click apply. And same data, but this time we're exposing a different component of the data. As you would expect, the further away you get from the center of town, the newer the properties. Looks like those expensive properties in the northwest of town are some of the newer subdivisions. They were built relatively recently. Some of the older buildings are right downtown. Again, as you would expect. So you can interact with your data in multiple ways to expose various components, essentially allowing your data to convey useful information in a geographic context. Now, one thing that's missing from this map, obviously if you're assigning colors as I have done, one of the things that's missing is a key or a legend that describes or shows me what those colors represent. That's an important part of this type of mapping exercise. I'm going to open up a window called the Map Layout Options window, a map layout setup window that allows me to add various elements to the layout of my map, including things like a scale bar, which is on by default. We can also add some text if we want to put a heading on the map, an elevation legend if we happen to have some elevation data. In my case, I'm going to apply a legend, and it's based on these loaded vector types. I can put a header. I'm just going to type in the word year for the time being. We can change any of the characteristics of the legend, the font and the position of the legend, etc. I'm just going to simply click OK on this to get my legend up there. And you'll see now the year is now noted. By the way, the 0, as you see indicated here, was our properties for which there was no year built assigned. So we assigned those to a 0. So here we have a more meaningful map where we can actually glance at the legend, glance at the map, and get that information. And again, the legend itself can be positioned in a more logical place, a more meaningful location. There's one final thing I'm going to show you in working with this parcel data before we shift focus and start to look at some elevation types of applications. For this example, I'm going to simulate the process of perhaps building a utility line across town. Maybe this is a pipeline or a transmission line or something of that type. And I'm going to do it very arbitrarily. I'm just simply going to draw a line. And you can see that line goes right through the middle of town. I'm not even going to spend the time to assign it to a recognized feature type. And we'll need to turn on our previous feature in order to do this. I'm going to actually, you know what, I'm going to close this and I'm going to do it one more time. We'll not save that. Let's go ahead and draw that line one more time. And again, we're simulating perhaps a pipeline, perhaps a transmission line, and we'll simply click OK in this case. Okay. The exercise now is to determine, based on this linear feature I've created, who's going to be impacted? Which property owners are going to have to be informed that there's a pipeline going through your backyard, or perhaps a transmission line is going to be strung overhead? Well, we're going to do a very quick analysis of this linear feature that will allow us to do that. And the first thing I'm going to do with this line feature is, as we did with our hydrants, I'm going to generate a buffer. In this case, it's buffering a line feature, so the end result will be an area, an elongated area. And it's going to be based on the radius that I select. And I'm going to assume that the extent of this particular project is going to be, let's say, 50 feet either side of the actual line feature itself. And when I create a buffer of that dimension, difficult to see at this scale, we'll zoom a little closer, you can see it's expanded the line to be an area. Now, this next procedure is very, very powerful, very straightforward in terms of how you implement it, but gives you a lot of useful information. Because I want to determine who is impacted by this particular project. I'm going to right-click on my map. I'm going to go to my advanced selection options for basically allowing me to filter the selection of particular features, and I'm going to choose the area features. In other words, I'm going to choose the properties, in this case the other layer that's on, that fall within this buffered area. Now I also have the option to include any part of the property, which is what I'm going to do in this case. So in other words, if any property owner has any part of their property impacted by this particular project, I will have a note of that. So we'll just go ahead and conduct that analysis, and you'll see highlighted on the map are those properties that fall within that area. Very simple, very useful. With those highlighted, once again, I can right click and I can apply a unique attribute to denote those as being impacted areas, or I could simply copy and paste them into a new layer. I'm not going to do that right now, but simply Control-C, Control-V allows me to take those properties, create a new layer, obviously focusing on those properties that I need to address, and work with that independently. So a number of things we can do based on that particular scenario or that analogy. For the time being, I'm going to return my parcels to their original visual state. So I'm going to go back to options. I'm going to use the default. Now I can come back and turn on the shaded pattern once again, but for the time being I'll go back to my orange parcels. We're going to be working with these again. I'm also going to turn off the legend because obviously we don't have particular colors now, so the legend isn't as meaningful. So we'll go ahead and turn that off. And we're going to shift focus slightly, and we're going to talk about elevation data. So far in our scenarios, we've talked about working with vectors. Our shapefile that we imported originally, those digitized parcels that we've been working with, those are vector features. We've also talked about working with raster layers. When we had our imagery imported to which we referenced the imported parcel layer, those were raster layers, so they were picture layers. The third type of data we're going to work with is elevation data. Now, it's a special type of layer. It is a raster format, but it's a raster format that includes some elevation intelligence. And you'll see how that's portrayed in just a second. How do we get elevation data? Well, many of the same sources that we use to get our vectors and our imagery, our rasters, can be used to get elevation data. There are some excellent online sources. You can get an elevation model generated by the U.S. Geological Survey covering the entire U.S. online, freely available. There are even worldwide data sets you can download, again, using the online data function. We're focusing on a little community in the state of Minnesota today. The state of Minnesota provides elevation data through its website. We noted that during our preview of some of the online sources. We could have gone to the elevation source and downloaded some elevation data from there as well. The specific format that we're going to be working with today is LiDAR data. Now, LiDAR is a up-and-coming data set. We're finding it more and more commonly available that provides a basis for creating a very accurate elevation or terrain or surface model. In its native format, LiDAR data is simply a series of points. And rather than just simply rambling on, I'm actually going to show you what that looks like. I have a sample of some LiDAR data covering the area that we're working in right now, covering the community of Hawley, Minnesota. Under my LiDAR folder, I have a file called hawleylidar.laz. This LAZ is actually a compressed version. Well, Global Mapper will import the compressed version or the uncompressed version. In its native format, LiDAR, as you will see, is a series of points, very closely spaced points. Each of those points includes an elevation value. It also includes a classification that determines or notes what the particular feature type is at that point, whether it's just simply a ground point or some vegetation or perhaps a building, depending on how the data was processed or collected. It can distinguish between those different surface types and allow you to generate different surface models based on those filtering processes. Today we're simply interested in the ground points, so I'm going to filter the import process to just include those ground points. And we'll just simply click OK. And when the status bar completes, we will see the end result of that process. I'm actually going to turn off my parcel, so we just have one layer visible right now. This is a layer of elevation data. Now, one of the things you will notice right off the bat is over here on the left side of my screen, I now have an elevation legend. It appears automatically with pre-assigned colors going from blue to red, denoting the elevation range within the extent of this layer that I've imported. You can, by the way, change this. The native elevation in this layer was meters, but you can very quickly change it to feet if necessary, just simply by right-clicking. So that's an option you have available. As I mentioned, the LiDAR data is a point formatted layer. In this case, the layer I just imported is actually 1.5 million points covering this area. That's actually a relatively small file. It's very common to have LiDAR data sets with 50, 100, or even 1 billion points. Global Mapper will work with virtually any size LiDAR data set. So if you're working with an entire county, it may take a little longer for you to import and process that data, but Global Mapper does support those large volumes of data. And as I said, in this case, it's a relatively small file. Now, as I mentioned, LiDAR is points. You'll notice breaks in this point array. These would be perhaps trees, or you'll notice some buildings perhaps as well. These are areas where we filtered out the points that we didn't need. We're only interested in the ground points. I'm going a little closer here, and you can see the individual points themselves. I do this so we can take a look at the horizontal scale, where you'll notice this is about 5 feet, perhaps just under 2 meters. These points are very closely spaced. Now, what we're going to do with these points is we're going to generate an elevation model by analyzing the precise height at each of these points, and you'll see how that works in just a second. Before we do, I want to show you the information that's associated with an individual point. I mentioned that each point has an elevation. This is precisely down to point thousandth of a meter. I guess that's a millimeter level accuracy here. The classification, we know all of the points I've imported are ground points, so we don't have any variation there. And a number of other pieces of information are also associated with each point. You can, in Global Mapper, change these points as well. For those of you who are looking at a more advanced application for LiDAR, we can edit either an individual point or a collection of points to reclassify them from ground to another type, or vice versa. Or you can even adjust the elevation if that's necessary. So there's a whole array of LiDAR processing tools in Global Mapper. Today, we're simply just interested in generating our elevation surface. Now, the way this works, and again, we're dealing with points right now, so we're going to have to do a little processing. We're simply going to right-click, and we're going to create a grid. A grid in this context is an elevation grid. We can apply what... Oh, actually, I apologize. I'm going to have to do one more thing before I do that. I'm going to define the boundary of my analysis here. I want to select my boundary. You may note that the extent of this data has now been outlined with a boundary of the town. I'm going to use that for the extent of my elevation analysis. So let's try that one more time. Again, choosing my LiDAR data, right click and grid. I'm going to use the default settings here, but I'm going to define the grid bounds as being cropped to my selected area feature, which again is the boundary of the town. And we'll click OK. Now this shouldn't take too long. Again, what it's doing is analyzing each of the points, analyzing the elevation associated with each of the points, initially generating a triangulated model, and from that creating a gridded surface. And that gridded surface is going to give us, as you'll see in just a second, a very precise terrain model that we can use for various other analysis functions within the software. In order to visualize what we have on screen, let's go ahead and turn off all of the other layers. And we'll just look at our elevation grid. And I'm going to zoom into the southeast section of town here. Now, as I said, let me use my zoom tool. And as I said, you can see very precise variations in elevation. One of the things that's automatically assigned to any elevation layer in Global Mapper is a hill shading pattern, and we can turn that off if necessary. So we actually just see the colors without that textural feel. The texture inserts an artificial shadow that really accentuates the terrain. We can change all of these characteristics. We could change the shader not to represent the actual elevation, but to represent slopes. So in this case, lighter colored areas would be flatter, darker colored areas would be relatively steep slopes. So another way of visualizing the same information. We can also show the area as a 3D model. Now in this case there's not a great deal of terrain variation. I'm going to increase the exaggeration slightly, and we can start to see those variations in terrain in our 3D model. And we can pan and move around in this model area. So generating a terrain surface from some LiDAR data, very straightforward process, and as you can see gives us a lot of useful information. This elevation grid we can also combine with any other loaded layer. I'm going to move my imagery layer down to the bottom of my list so it actually will appear on the top of the map. I'm going to turn it on so we will have a visual representation of the actual features. This happens to be a golf course, and underneath, using my image swipe tool as we did previously, we can see that the elevation data is still there. Now with those two combined layers, if we open our 3D model once again, you'll see we'll now get the best of both worlds. We get the terrain derived from our elevation data, and we get our imagery to see the actual physical features. It gives us a very realistic perspective of the terrain. While we have this 3D map open, I want to show you one other function that we can initiate within Global Mapper. There are various tools in the software to apply flooding models, simulating rising seawater. There are various ways of visualizing and for analyzing that. The one I'm going to show you right now is right here within the 3D window, where we can stipulate a water level. And I'm going to type in approximately 350 meters, which represents the terrain in this area. And we'll just go ahead and turn that on and apply. And you'll see what that looks like when we apply it. And we can actually use our slider to increase or decrease the extent of our intrusion, as you can see. So we can do a very visually appealing water analysis function here to show where the water level rise would be, in a flooding situation, for instance, who's going to be impacted. Again, I mentioned there are another couple of tools that can allow you to do this as well. This is the one that we can apply within the 3D window within this terrain model. Another tool, a very simple tool that we can apply now that we have some elevation data, is a profiling tool. Quite simply, it allows us to denote a linear feature, either a pre-existing line feature, or we can create our own line feature, and we can get a cross-sectional profile of the terrain. Now I have to mention that this cross-sectional profile is extremely exaggerated based on the extent of my window. The actual change in elevation is not that great, over only 30 feet over the course of about half a mile, as you can see. But it does accentuate the terrain, allowing you to see various the changes in the landscape across that linear feature. That's another tool that we have available. Perhaps one of the more useful components of working with elevation data is the ability to generate contours. Now, I'm going to do this for a localized area in the interest of time here. In the analysis menu, there is a generate contours option right here. And generating contours is as simple as specifying a particular interval based on your requirements. Obviously, with the higher quality elevation data that we derive from this LiDAR layer, we can generate very precise, very low contour intervals. In other words, 1 meter or perhaps half meter contour intervals, or 1 foot or perhaps 2 feet contour intervals. And we can specify the resolution if necessary. We can also specify the extent of our contours. And in this case, I'm going to limit this analysis just to a small area, so we can see the results pretty quickly. All I've done is delineate a box, and we'll generate 1 meter contours for that area. And you can see the result. Let me zoom in on the area that we generated the contours for, and you can see very precise, very easy to create contour features. These are vector features. These are simply line features that were generated in a vector form. You can see I used my info tool to select one, and in that format they can be very easily exported in any of the supported formats to any other platform. So in this context, you can see Global Mapper as simply a tool for generating contours. The process is very straightforward, very quick, and gives you very precise contour coverage. Next analysis function I want to show you involves the hypothetical delineation of what we would define as a watershed. Now, a watershed is an area feature that denotes the flow into a particular drainage system, and this is very often used when monitoring public water supplies, when monitoring contamination, perhaps contamination of groundwater. I have pre-created a little point feature here called water supply that I'm going to assume is my public water supply area just for this particular scenario. I'm going to select that point because what I want to do is I want to denote the extent of the area based on this terrain model that flows to this access point for my water supply. In other words, I want to know where I need to draw the line as far as development, as far as any regulatory issues are concerned. And I do this by going to the analysis menu and opening up the Generate Watershed dialog box. I'm going to generate the flow to a selected point. I'm actually going to change my resolution very quickly to speed up the process, and I think everything else should be fine. Let me limit this to my screen once again so we're not analyzing data we don't need to, and we'll simply click OK. And as a result of this process, we'll see a delineated water supply area as denoted with our pink boundary. As you can see, this, in a very hypothetical way, denotes the extent of the area that we would need to protect if this was actually a water supply. You will also notice in this model we have these blue linear features. These would represent the hypothetical drainage channels, and you can see those scattered throughout my, my elevation model. Now, to put this in a little more practical context, I'm first going to select the boundary feature that I just created. It's outlined with yellow now, indicating it's been selected. I'm going to turn on my parcels. Let me turn off my drainage network first. I'm going to turn on my parcels. Oops, try that one more time. And I'm going to determine which parcels are going to be within my watershed boundary. Again, same as we had done previously. We go to our advanced selection options, choose those area features that are within my watershed, even any overlap, and again you'll see those denoted as being highlighted on the screen. So very quickly, using this elevation model, I was able to determine my watershed extent and to note or to capture those properties that fall within those boundaries. So watershed modeling, another key part of the analysis capability of the software. Let's go ahead and go back to our parcel record again. To this point, we've addressed the challenge of getting data into the software. We've done a little bit of processing and analysis. We've derived information from our imported or created data sets. In other words, we've allowed the data to convey useful information to help us in certain decision-making processes. We're at the point in the presentation now where we need to address the export or sharing of our data. Now that we've performed those analysis, now that we've created our parcel record, we need to have a mechanism to distribute that. And there are various ways of doing that. As I noted a few minutes ago, we have an array of map layout functions, allowing you to put a heading on your map or whatever accompanying text is needed, to put a scale if necessary. If you're working with elevation data, to include an elevation legend on your map. We have an option to put boundary or a margin or boundaries around the edge of your map, so you can really develop a very high quality presentation style map. Ultimately, you could then print that map. Obviously, with Global Mapper, there's an array of print functionality. If you've got a large format printer, you can simply output your map and have it in a printed form. For many municipalities, for many government organizations, that is the way they distribute the map information. Printing is a key part of Global Mapper as well. You can output some very high quality printed maps. Unfortunately, it's not something I can demonstrate during the webinar because you can't see the result of that process. Related to printing is the ability to generate a PDF. PDF setup process is almost the same as the print setup process, where we can define the page size, define a scale if necessary, and rather than sending our file to a printer, we would send it to a PDF file. The really interesting thing about the PDFs that are generated within Global Mapper is they retain their geographic intelligence. In other words, you're going to generate not just a flat PDF, but a geospatial PDF, so that the viewer of the PDF will see the geographically referenced information. They can measure geographically, they can see the coordinates, and if you export multiple layers, they will have the ability to turn layers on or off as needed. So you have that distribution mechanism as well, and it's one that's becoming increasingly important working with PDFs. Obviously, regardless of what platform you work on or what distribution method, most people can open up a PDF on their home computer or on their work computer. So those are just two examples of accessing or getting data out of the software. It is important as well to mention the file export functionality. We imported a shapefile. If our goal is to export a file in a different format, we go to the export dialog box, we export our raster formatted data, our vector formatted data, and we choose an alternative format. You'll notice, again, long list of supported vector formats in this case, where we can send this data to another platform, perhaps another GIS program, or perhaps some other proprietary format that's needed in a particular application. Global Mapper is the epitome of interoperability in that regard. It allows you to talk both importing and exporting with many, many applications. We can also write directly into ArcSDE, so or any of the other common spatial database formats. You'll notice we can export directly to a spatial database. So if you're working again within a current and existing GIS infrastructure, Global Mapper can tie directly into your data, both in terms of accessing data and exporting data. So those are just some of the file export capabilities of the software. The one thing I do want to show you by way of wrapping up is a distribution mechanism that allows you to take any data on your map and publish it to a universally accessible website. And I'm going to do this, assuming the connection will work for me today, I'm going to do this based on some localized parcel data. Under my file menu, in the export submenu, there is an export web format option. Under the export web format selection, we can choose from a number of pre-configured format options, including things like Google Map Tiles, which is a raster tile structure that will integrate into a Google Maps framework. Same with Bing Maps. We have some proprietary formats here, some application-specific formats. We also have the ability to export KML files. KML being Keyhole Markup Language, which is Google Maps native format. And we're actually going to generate a small KML file and show you how you can distribute that to your constituents using a readily available web mechanism. So I'm going to use that format. I'm going to select OK in this case, and I'm going to leave all of the default settings as they are, but the one thing I do want to do is limit the export to a very small area. I'm just going to choose a small subsection of my data in the interests of time. And we'll click OK. And obviously in your case, if you're following this workflow, you can do this with your entire parcel record and ultimately have your parcel data available online in a very short period of time. So we'll select that file. I'm going to go to my desktop. I'm just going to save this on my desktop. I'm going to call it Parcels, and it's going to be a compressed KML file, a KMZ file, and we'll simply hit save. And in order to show this in context, I'm going to go back into my browser, and I'm going to go to Google Maps. Many of you have used Google Maps. You're familiar with this framework. I'm simply going to create a new map publicly available by importing the file I just exported. I'm going to go to my desktop once again, and there's my Parcels layer, just a small subsection of my Parcels, and I will upload that from the file. And you'll see a small section here of the parcel information. To make this more meaningful, I'm actually going to take the link itself. I'm going to paste that into a new browser window. Let's try that one more time. Again, we'll take the link. Let me close that and open it one more time. There we go. Let's copy that, and we'll paste it up here. And what you'll see is ultimately what your constituents would see. This is now an out-facing, publicly accessible, interactive map that I generated in seconds. Using the standard Google Maps framework, I can select a parcel to get whatever information is associated with that parcel. And obviously in the real world, you may want to do a little more time, spend a little more time filtering what information is distributed to your constituents. But using the standard Google Maps interface and Global Mapper as your data management tool, you can distribute this parcel information very quickly and very easily. And as I said, this took me literally seconds to publish. So, file distribution, printing, PDF generation, web publishing. Those are just some of the examples of how you can take your data from within Global Mapper and distribute it to your constituents. By way of wrapping up, we introduced the idea of accessible GIS at the beginning of our presentation, and we're going to define that in a little more detail. We like to think that Global Mapper empowers municipalities of every size to be self-sufficient in the development and management of their GIS. Basically, you can do this work yourself. Everything I did over the course of this webinar, over the course of my presentation, can be done by virtually anybody. It's not difficult. You can develop your GIS regardless of any budget issues. We'd introduced the price point at the start. $400 for the software. That's well within the budget of most municipalities. You do not have to be highly trained. You do not have to have a lot of existing technical know-how to run the software. It's very straightforward, using a lot of very standard procedures. It's very easy to build and maintain your GIS. You do not have to have a complex existing IT infrastructure. This will install on a local PC and allow you to manage your data locally without any existing IT infrastructure. You do not have to rely on a particular format of data. One of the key characteristics, as we mentioned at the start, is Global Mapper's format support, the ability to work with data in virtually any format. That list is increasing continually. So if you have access to data that's not currently supported, we encourage you to let us know. We'll see if we can add that one to the supported list as well. That should not be a constraint in terms of the development of your GIS. Your current hardware setup, it does not require a high-end computer. Virtually any currently available PC or laptop computer can run Global Mapper very easily. It's a very small footprint. Your data delivery requirements should not be a constraint. In other words, if your clients or your customers or whoever you work with or the state within which you reside requires data to be delivered in a particular format, Global Mapper will do that for you. We do support so many different file formats as far as exporting is concerned. You will satisfy those requirements. We can guarantee that. You do not have to hire someone to run this system. I talk with a lot of municipal officials who do the GIS work in their spare time when they're not doing their day job. They will manage their data. They will build and maintain their GIS data on a kind of available time basis. Global Mapper provides the GIS tools that are well within the reach of non-GIS professionals. And I'm assuming today we're talking to a number of people, perhaps the majority of attendees in this webinar would consider themselves to be non-GIS professionals. Global Mapper will give you the tools that will let you develop and manage your GIS infrastructure regardless of any of these constraints. Thank you very much for taking time to attend the webinar. As you'll see on my screen, we have a number of web addresses and contact emails where you can contact us, and if you've product questions or follow-up questions to our webinar, you can use the GeoHelp email address. If you're interested in information about ordering the software, use a GM Orders email address. Or if you're interested in having some training, you can email training@bluemarblegeo.com as well. Perhaps the most important part of this slide is the last. If you're not currently using Global Mapper, here is the location where you can download a copy and you can install it and try it out for free. It's a free 2-week trial. During that time, if you have questions about the features and functions, feel free to contact us using the address you see here. We'll help you answer your questions and hopefully get you up and running. If during that trial period you're interested in purchasing a permanent license, you can do that right online. We simply provide you with an automated access code that's automatically integrated. Once you enter your order number, it's all done for you. You will have continual use of the software thereafter. There is no upgrade required. There's no maintenance fee required. Once again, thank you for attending. Hopefully we provided useful information on the application of Global Mapper for municipal government.